on to the next set. Example 32 from page 193. Simplify using m over n. So you subtract these, right? And again, you can only do this as long as the bases are the same. So notice the 7's are the same, the b's are the same, so you can do the subtraction. 7 to the 8 minus 5 gives us 7 to the third. Okay. B to the 6 minus m. Again, you can't take 6 minus m and simplify that, so you just leave it as b to the 6 minus m. All right? Okay, next set of examples. Example 33 from page 193. Okay? Now we're going to multiply these exponents. When you have it's called power raised to a power. So when you have a power raised to a power, you multiply the exponent. So this is 2 to the 4 times 3, which is 2 to the 12th. X to the 3 times 5, which is x to the 15th. And this is b to the 7 times m. And again, you can't really simplify that. It might look a little nicer to just write b to the 7m without the little multiplication sign in between. All right? Okay. Next set of examples. Example 34 from page 193. Express in simplest form with a prime number base. So this is a little different here. This isn't dealing directly with our formulas, but we have to do something first. So a prime number base. 9's not a prime number, it's a perfect square. So what they're asking us to do here is turn 9 into something that you can multiply together to get 9. So 9 is the same thing as 3 squared, right? So I'm going to replace that 9 with 3 squared. So really what they're saying, this is 3 squared to the 4th. Right? And then now we're back to the power to a power rule. So we go 3 to the 2 times 4 is 3 to the 8th. So 9 to the 4th is the same thing as 3 to the 8th. And you can always, if you're like, well, wait a minute, that doesn't sound right, you can always double check these, especially if they give you, well, you can only double check them if you've got actual values in there. So let's do this. 9 to the 4th gives us 65, 61. Let's see what 3, oops, not 33, but 3 to the 8th gives us 65, 61. So these 9 to the 4th is the same thing as 3 to the 8th. Alright? So, next one. 4 times 2 to the p power. 4 can be written as 2 squared. So we're going to do this. 2 squared times 2 to the p. So this is just going to be 2 to the 2p, because you multiply 2 times p to get 2p. Alright? C, 3 to the x over 9 to the y. We know that 9 is 3 squared. So we're going to turn this into 3 to the x over 3 squared to the y. Okay? Now, on the bottom, let's see, we have 3 to the x on the top, and on the bottom it's 3 to the 2y, right? And simplest form means to get these 3's, we have the same bases, get them together. So since we have one over the top of the other, we have a fraction. You subtract these. And again, the way that I remember that is you take this, I see this fraction as a big negative sign. So this is really 3 to the x. And there's my big negative sign, minus 2y. And again, you can't simplify that, so that is our answer. Okay? So again, think of that as a big subtraction sign. And then this one here, 25 to the x minus 1. 25 is just 5 squared. So that's 5 squared to the x minus 1. Okay? So really, you're going to take this 2 and you're going to distribute it through to both of those. So this is going to be 5 to the 2x, and then 2 times negative 1 is negative 2. So that's 5 to the 2x minus 2 on that one. Alright? Okay. Next set of examples. Example 35 from page 194. Remove the brackets of this. So basically it means distribute that 3 through and distribute the 4 through. I find it handy to, and it helps me to not make nearly as many errors whenever I see numbers and variables in here without powers. I'm always going to put a 1 next to them just so that I don't forget. So now I know that I go 3 times 1 and 3 times 1 there, so that's 2 to the third, x to the third. And that's all you can do. Okay? Same thing here, 3 to the first, c to the first, b to the first. So this is going to be 3 to the fourth, because again we're going to multiply 4 by that, and by that, all these powers of 1. Okay, so that's 3 to the fourth, c to the fourth, over b to the fourth. So you could write that, you could write it like this, or you could move that b to the fourth back up to the top and write that as 3 to the fourth, c to the fourth, b to the, since we moved it from the bottom back to the top, it would be b to the negative fourth. You could do either or. They didn't specify that you need to write it without fractions or whatever, so you can do either one of these is fine. Eventually they might ask you to write your answers without fractions, or sometimes they might ask you to write your answers without negative exponents, and in this case you'd have to write it like this. Okay? Alright. Next set of examples. Example 36 from page 194. Again, similar to what we just did here, except for some of these now actually have some other powers in there. So again, I'm going to write 1 with that one, a 1 with this one, and then distribute my 4, power of 4 to all of those. So that's 3 to the fourth, a to the 12th, b to the 4th. And you can just leave it like that. If you want to calculate out what 3 to the 4th is, you can write it down if you want to, but this is just fine. Okay? There's my x squared, and I know that that's 2 to the first and y to the first down there. Multiply all these exponents by 3, so that's x to the 6th over 2 cubed y cubed. Okay, which again is just fine. You could move those exponents up and turn them to negatives if you want, but again it doesn't specify, so you can just leave it. Okay? Alright. We're doing great. We're getting close. So, next set of examples. Example 37 from page 195. Simplify using the index laws. So this one here, these here often will start messing people up. Okay? What you want to do is you want to separate the constants from the variables with powers. Okay? So really what we want to do is I'm going to rewrite this as 3 times 5 times x squared times x to the 5th. Okay, so I'm going to put my constants together and I'm going to put my variables together. So the 3 times 5 is going to give me 15, and then 2, since we're not taking a power to the power, we're just multiplying these here. X squared times x to the 5th, we add those, so that's going to be x to the 2 plus 5, or just 15 x to the 7th would be our answer for that. Okay. Same thing over here. I just want to think of these as 2 separate little problems. 20 divided by 4 gives me 5, and then a to the 9 minus, again this is a big subtraction sign, 9 minus 6. So this is going to be 5a cubed. Okay? So again, take care of the constants together and then take care of the variables together, but they don't follow the same rules, because these you subtract and these you actually divide, right? Okay. A little confusing, but again, the more you practice it, the more it starts to make sense. Okay, this one here, I'm going to simplify the numerator and then simplify the denominator and then simplify them all together. So that's going to be b to the 3 plus 7 all over b to the 2 times 4, because that's a power raised to a power. So this is b to the Let's do this. Let's do little squigglies so we know where our different steps are. So this is, in fact, let's even do it in different color. Make it even easier to see. Oops, I shouldn't cross it out. That doesn't help. So there's 1. And then now we do this. 3 plus 7 gives us b to the 10th. Over 2 times 4 is b to the 8th. Right? So now we're going to do b to the 10 minus 8, which gives us b squared. So this big mess up here ends up just being the same as b squared. All right?